Hello everyone, and a warm welcome to our presentation on DigitalOcean Kubernetes Networking Reimagined. We are thrilled to have you here. This session is scheduled to run for an hour with a good chunk of it dedicated to your questions. We want to really keep it interactive as possible, and so appreciate all your engagements. I already see that folks are chiming in, and let's give it a minute or so to for everyone to join. In the meantime, please feel free to say hi in the chat and let us know where you are joining from. I see Churchill. Hi, Churchill. Mohammed from Morocco. Hi, Mohammed. Thanks for joining. Heikki from Finland. Hello, Martin. Hi, Martin. Okay, I see quite a few folks joining. Hi, Kevin. Hello, Umar, joining from Pakistan. And then we have David from Canada. Cool. Seems like we have a quorum and we are ready to get started. We have got an hour together today, and here is how we'll spend it. First, we'll walk through the exciting new features of DOKS networking and show you how these updates make it easier to simplify and scale. This will also include a live demo. Then we'll dedicate the last 30 minutes entirely to your questions. Now, let me introduce myself and our team. My name is Bikram Gupta, and I'm the product manager for Kubernetes here at DigitalOcean. I have a deep background in networking and security, and so I'm thrilled to be sharing these updates with you today. Uday, would you like to introduce yourself?
Sure. Thanks, Bikram. My name is Uday. I'm the product manager for networking products here at DigitalOcean, and I'm been here for about 2-3 years.
Thanks, Uday. And Ingo, over to you.
Hi, I'm Ingo Gottwald. I'm at DO for 4 years now and the tech lead for DOKS for a couple of months now. And yeah, I've been working in Kubernetes since the inception, I would say. It was one of the very early ones.
Yeah, super expert in Kubernetes. And finally, Braden, please introduce yourself.
Hi, everyone. Staff engineer, primarily working on load balancers and on the networking side. Also the tech lead for our load balancing products, which include our global load balancer and our regional load balancer. And then kind of recently, we launched our internal load balancer and also our upcoming network load balancer as well.
Thank you, Braden. And we have like so many questions that we got during the registration on load balancer. And those who are attending, you'll be hearing directly from the people who built it. Before we dive in, a very quick note on logistics. Now, we are going to make the slides available online. They'll be shared with you. The recording will be posted to YouTube. And so don't worry about taking any screenshots. Just focus on listening and engaging and interacting in the chat. Let's start by briefly describing the previous state of networking in DOKS. By the way, I'll be using the word DOKS and DOKS interchangeably. They both refer to DigitalOcean Kubernetes. As you can see in this diagram, DOKS operated in an isolated network of its own. And many of you who are here using DOKS, you know that it is separate from the VPC. While the worker nodes are part of the VPC, the pod and the service networks, they use Cilium and they are isolated from the VPC. This makes communication between DOKS resources and the VPC resources challenging. For example, if a Kubernetes workload or a Kubernetes pod wanted to connect directly to a database or a droplet in the VPC, it can directly connect, but the connection was NATed. On the reverse side, though, it's more restrictive. You cannot directly connect from a droplet to a Kubernetes service or a Kubernetes pod. You had to route through the public load balancer that we had. And so the traffic invariably used to go through the internet. Similarly, if you managed multiple clusters, whether in the same region, in different VPCs, or in different regions, there was no way to peer them directly. The only option if you wanted to communicate between the clusters was through the load balancer, which is again the traffic going through the public network. So to summarize, the main challenges that we had were isolated Kubernetes network, limited geographical flexibility, and lack of private load balancing. We had heard a lot of feedbacks from many of you, and we really worked hard on this in the last year. So we are really thrilled to introduce a new set of capabilities that directly address these challenges. While the DOKS continues to use Cilium, Cilium is the best-in-class container network CNI. The key change that we made is that now the pod and service network use the IP address space from the VPC pool. And that's what we call a VPC-Native DOKS cluster. It means now the VPC resources like droplets can directly communicate with the DOKS resources, the pods, because they are part of the same network. And to ensure the communication across regions or across VPCs, we have designed the system so that the VPCs in different data centers, they require unique IP address or CIDR ranges. So when the VPCs are peered together, the resources in the VPCs, the resources in the DOKS clusters can communicate natively because they are part of different network, but now they are peered together. There is no additional configuration that you have to do. Now let's talk about the load balancing aspect. To meet the demands for scalable communication when your application or service is deployed across different regions, or when you're trying to really connect privately between the VPC resources, we have introduced two different load balancers. The global load balancer can help you deploy a single service across multiple clusters in different data centers, and you can seamlessly load balance the traffic between them. And then internal load balancer, while you can connect from a droplet to a pod directly, you want to use a Kubernetes service because that allows you to scale to n number of pods. Service is a logical front end. And so by using the internal load balancer, you can have scalable and private communication between the VPC resources and a DOKS service. You can actually start with the foundational building blocks. You don't have to adopt everything. You start with the VPC-Native DOKS cluster. It future-proofs your architecture. And then from there, you can integrate additional components into your application stacks as your requirements evolve and as you start to scale. This paradigm empowers you to build a really global and resilient application while maintaining simplicity and ease of use. With that, now let me hand over to Uday to demonstrate all these exciting capabilities in action.
Thank you, Bikram. Can I start sharing the screen?
Yes, please, Uday. Yeah, go ahead.
Okay. Okay, I'm going to move between tabs and demo screens. So to start with, in this demo, we're going to look into how do you scale your application workloads beyond a single DC using VPC Peering, VPC-Native DOKS cluster, global load balancers, as mentioned by Bikram. So we are going to take 3 specific use cases here. First one is, how do we privately access a DOKS cluster in New York region from a droplet in London region? And second one is, how do we access a MongoDB cluster in London one from a DOKS cluster in NYC one? And finally, we're going to look into how do we make the DOKS service available globally using a global load balancer. Now, to start with, the first use case, how can we privately access a DOKS cluster in NYC1 from a droplet in London 1? Before diving into the demo, just want to give high-level overview about the steps involved in it. As part of this demo, I have already created the droplet and VPC-Native cluster, but step 1 is you need to create a droplet in London 1, and second, you need to create a VPC-Native cluster in NYC1. Now, what does VPC-Native cluster mean is, as iterated by Bikram, involves 3 steps. First is you need to understand what are the existing service subnet and the cluster subnet available for you to pick to be assigned when you create a VPC-Native cluster. So we have 3 commands that you can run. DOKS VPCs list will list all the VPCs for you, and this listing the service and cluster subnet command helps you to extract what are the service subnet and cluster subnet that's been already created in your Kubernetes cluster. And finally, from that information, you can run this command to create a VPC-Native cluster. Now, what will this do? It will create a cluster net. It will enable you to have the cluster services and pods with addresses that is routable within the VPC network. And then you can create a Kubernetes service and expose it using an ILB which is routable in the VPC network. That can be done using annotations. Now, this is the annotation command that you have to add in your YAML, service YAML. And then finally, you have to create a VPC peering between London 1 and NYC1. So these are the 4 key steps involved in order to privately enable this access of a DOKS cluster in NYC1 to be able to reached from other region in droplet 1. So let me show a quick demo on this. So before jumping in, I want to point out that I have created a droplet in London 1. I'm going to access this London 1 droplet 1 from the Kubernetes cluster in New York. So I've already created a VPC-Native cluster in New York. As you can see, DOKS VPC-Native in here. Now, going back to the terminal screen, what I'm going to do is I'm going to try, you can see on the left is the Kubernetes service, ILB service that's having an external IP 10.116.06, which is basically the routable IP.
Uday?
Yes.
We have a request from the chat. Can you please zoom in a bit?
Oh, sure. Is it viewable now?
Try just a little more. Yeah. Thank you.
Okay. So just to reiterate, I have created the Kubernetes VPC-Native Kubernetes cluster, and I have created the ILB service by which I'm exposing the Kubernetes application over the VPC network. And if you can see, it is getting an external IP, which is routable over the VPC network. Now, onto the left, I have SSH'd into the droplet in London 1. I'm trying to ping this IP, trying to reach it, which I cannot as of now, because there is no VPC peering involved between NYC region and London 1 region. So let's now go and enable. Sorry.
We're looking at the Chrome window.
Oh,
are you in the terminal or?
Sorry, 1 second.
Yes, guys, we are just looking at the logistics. I think Uday, you have to share the screen so that you can switch between the browser and the terminal.
Let me know if everybody can see the screen.
Yeah, and you might have to zoom in just a little bit. Yeah.
Is this good?
Yes.
Okay, sorry about this. So I'll just quickly iterate it. Onto the left, you're seeing the Kubernetes cluster screen. Onto the right, you're seeing the droplet SSH screen. On the left, as you can see, I have created the Kubernetes cluster in NYC1, as you can see here, and I have exposed the application over using the ILB service. Now, the ILB is the internal load balancer. Once, as I created this VPC-Native cluster and exposed this service, you can see it is getting an external IP address, which is routable over the VPC network. And onto the right, I'm SSHing into the London 1 droplet, and I'm trying to ping this address, that's routable address. Currently, the ping doesn't work. It's because we don't have VPC peering enabled between these two regions, that is New York and London. Now, what we are going to do is we are going to enable VPC peering and try to see if it works. Now, going back to the console, I'm going to go to the networking section, go to VPC, and as you can see, you have this default NYC. There is no peering connections in this network. So I'm going to create a VPC peering from this default NYC VPC to London 1 VPC. I'm going to leave the name as it is. It may take a couple of seconds for it to create. Yeah, it's created. Now let's go back to there you go. Back to the terminal where you can see the ping works. And I'm going to also curl the IP. Now, since it's just showing up a web page, welcome to Partner, which is what I have behind that application. So there you go. So what we have demonstrated here is privately, you can access a Kubernetes cluster from a different region by exposing the application over using an ILB service and leveraging the VPC peering between the two regions. This is the first use case. Now going to the second use case. Now the second use case is how do we access a database from Kubernetes? Now what we are doing here is we're going to create a database, MongoDB database in London 1, and we will try to access it from the Kubernetes cluster, VPC-Native Kubernetes cluster, which we just created in NYC1. So what I'm going to do here is there are only a few steps here. I'm going to SSH into the Kubernetes pod, and I have already installed the Mongo SH client into the pod. So all I'm going to do is I have already created the MongoDB database as well. All I'm going to try is, since we have already enabled the VPC peering, I should be able to access the database from, which is in London 1, from the Kubernetes cluster in New York. So let's test that. So here, I'm going to SSH into the pod, which is in New York, and get the command. For that, I'll also show you what I have on London 1 in the database side. So I have this DB MongoDB London 1 demo database, which is in London 1. So this is the database I'm going to access. In order to access, all you have to do is go to the VPC network here and use this command, or use this domain host name and use the password to connect. So I'm going to test that out. As you can see, it's trying to connect, and it's got connected to the database from the Kubernetes pod, which is in New York. So that's our second use case. So what we did now is we tried to connect from a Kubernetes cluster in New York to a database, MongoDB database in London 1. And moving on to the final use case, which is how do we make this DOKS service accessible globally? In this, there are only two additional steps. I'm going to leverage the existing setup where we're going to use the same Kubernetes ILB. What we are going to do is we will connect the ILB to a GLB, connect to a global load balancer, and connect a domain to it. The moment you connect domain, you can add as many regional load balancers to a global load balancer. So just like in the a demonstration in the diagram where you can have multiple redundant services and connect to those ILBs to a GLB so that you can increase the global accessibility and reliability of your application. Now let's demo that. Let's go to the networking section and create a global load balancer here. I'm going to keep rest of the setting as same. Only thing is in the connect resources section, I'm going to connect the Kubernetes ILB New York one. This is the regional ILB service that hosts that application. Now I'm going to keep the rest of the settings as same. I'm going to select the project and create a global load balancer. So while creating, since I already connected, I'm going to continue. One thing is I need to connect a domain here. I've already created a domain already added to the domain section of DigitalOcean. So I'm going to leave this as is and continue. So it will take a couple of seconds for it to validate the domain. Once the validation is done, it will show up as healthy. In this scenario, as you can see, the ILB gets connected to the global load balancer and domain validation is in progress. Once this is complete, we're going to try to access the domain and see if it reaches the application. While it takes the validation, while it does the validation, I see a couple of questions. What is the process for existing clusters? Currently, all Kubernetes clusters get the same CIDR. Ingo, you want to take it?
Hold on, I need to check the question.
Sure.
Well, for VPC-Native clusters, you have to select different CIDRs from the current one. Currently, every cluster gets the same because the subnets are virtual. They're not known to the VPC. They're just inside of the cluster. And only the cluster understands it and knows how to route to it. For VPC native ones, you have to choose subnets from the VPC. And at DO, for simplicity reasons, you cannot have an overlap of CIDRs, like VPC and the clusters, because that would cause routing issues for you that make it difficult if you have an accidental overlap to route from one network to the other. So that's why we check this up front, and will only allow you to insert subnets that would make sense.
One other thing I want to also
It's
mention.
the existing cluster, Ingo.
Yeah, existing clusters, you would have to recreate a cluster, a new one, and migrate the workload, because Kubernetes does not really have a support for completely swapping out the network. There are some integrations in Cilium that have support for expanding the ranges that were chosen by adding like new ranges to the pod range. But a complete swap out is not really supported, and would be equal to just shutting down all the workload and starting with a new IP range. And you probably don't want to have that either. So the best scenario for this is to create a new VPC native cluster next to it and just migrate over.
Thanks, Ingo. So I'm going to finish this up where you can see the domain validation was done, and the moment we access the domain, it points to the web page that we just saw in the internal ILB testing. So that's it for the demo. We saw 3 use cases. How can we leverage VPC peering and global load balancer to make DOKS services accessible globally, scale irrespective of the region, and also ensure security by using ILB, which is accessible within the VPC network. Over to you, Bikram. I will stop the screen sharing. Oh, you're on mute, Bikram.
Yeah, thanks, Uday. And it's good to see that we have gotten to start. We are seeing a bunch of questions coming in. I'm just looking at the questions to see where we start, because we also got a lot of questions during the registration page. And so to keep it simple, the way we'll do is we've got good 30 minutes. We'll just go through the questions in a structured manner and make sure that we are addressing all the questions that we got during the registration and the questions that we are getting live here. So let me start with the first question around the architecture and design, which is Braden. One question we had was for multi-region deployment with identical services using global load balancer and DOKS. What are the recommended approaches for database synchronization? Because if you have DOKS cluster in different regions, you do have databases as well, right?
Yeah, exactly. So if you're using our managed DPaaS products, we do have support for adding read replicas from one data center to another. So this would allow you to have local read-only queries to your database from multiple data centers. But at the moment, your writes would always have to go back to that kind of primary data center. There is support for performing a failover if you're needing to do that, but that's something that's kind of specific to your application and then what you're kind of needing to accomplish for availability and latency.
Perfect. Thank you, Braden. Let me go to the next question, which is Ingo, you spoke briefly about the CIDR range planning for the DOKS clusters. So one question we had gotten during from an attendee was, what's the recommended side or range sizing strategy for node, pod, and service networks? If I have to create 4 or 5 VPC-Native clusters, how do I really do it in a simple manner?
That mostly depends on the size of clusters you want to run. And obviously, everyone should keep some network headroom in mind for sizing those, because expanding is rather difficult. And since we cannot have overlap, this also, like the available private IP space, kind of limits how much clusters you can create if you make them really, really big. But a one size fits many from our perspective would be like a /16 for the pod network. That would give you roughly over 500 nodes, and a /19 for the service network gives you over 8,000 possible services. From the data we've seen with many customers, they can go very far with that setup and can have multiple clusters of that size. Although there are some who want to go even bigger, and then we definitely want to talk to you some more, because there's some planning involved to run these kinds of setups.
Yeah, I mean, that's lovely. So and if you're trying to scale really beyond 512 nodes or so, then we would love to talk to you. But the good news is that very soon we are also going to support much larger node sizes. The next question for you, Ingo, again. We described about peering the DOKS clusters, but can you explain how the cross-cluster service discovery and DNS resolution will work?
So thinking of like local DNS in terms of core DNS, that is still cluster scoped. So each cluster has its own core DNS. Of course, you can use any DNS service and manage that on top. If you want to have some, DNS coordination between the clusters, you could also run an additional service discovery mechanism to figure out where traffic should be going. The easiest one is, of course, to use our load balancer products, especially like global load balancer, which would do that automatically for you and then route to the closest one.
Got it. And Felix, you had the same questions, so hopefully this answers your question. I'm just watching the chat and making sure that we are answering the questions as we go. Okay, so now let's get to the next question, which is Braden, we have a question for you. How does the global load balancer determine the nearest data center for traffic routing, and what factors influence this decision?
Right. So we have many locations that we ingress traffic from, and wherever your clients are connecting from, by default, we always try to route their traffic to your nearest healthy application. So there's a couple of decisions that we use to do that. One is we look at the latency between where traffic is coming from and where your application is deployed. So we always try to make sure that we route traffic to the lowest latency origin. But we also look at other factors such as load and the healthiness of your application in that data center. We do also have support for adding priorities to data centers. So if you're looking for more of like an active passive setup where everything gets routed to one data center, and if that becomes unhealthy or fails, we would fail over to another data center. So that's kind of up to your application and what you're wanting to achieve. But it's all in kind of the global load balancer settings.
Thanks, Braden. I see that quite a few questions coming on the egress gateway, the internet gateway aspect. So let's cover that first. Ingo and Uday, do you want to take up this question? Like, what are the options for maintaining a static egress addresses from DOKS cluster? What do we have today and what will be in the roadmap? Ingo?
Okay, so today we have this kind of blueprint solution that you host your own. It's an open source thing. I think we even have a blog post about it. I think Bikram, you shared it in the chat. It always has two components. It has like a route operator that lives in the cluster and just inserts certain routes that point to a gateway, and then it has a gateway component outside of the cluster. Since this is pretty much self-managed, there's some setup involved, and the good news is we want to make this easier and follow up with a product that would take over the gateway component, and then of course more tightly integrated into the DOKS product. The reason why we're shifting here a bit is because it makes more sense for users when this is a real network VPC product, because then it works the same for Kubernetes clusters as it does for droplets you might run on the side for different applications, and you're much more flexible that way. I think we cannot share a timeline today, but I think soon is a good word for when it's coming.
We are actively working, yes. Uday, do you want to talk about the plans for the VPC Internet Gateway?
Yes, Bikram. We are going to have a managed NAT gateway product from the networking side, where the idea is you should be able to connect your VPCs to route traffic through the managed NAT gateway, where you don't have to manually set anything up. All you have to use that gateway and point that to the necessary workloads for you to egress on. It will help you have the singular IP that you don't have to worry about, and that's the idea. But as Bikram said, we will launch it soon. We cannot communicate the timeline though, but it's coming, and once it is out, you should be able to easily leverage it to and move away from the complex setup you have, manual setup that you have in DOKS.
Perfect. We have quite a few questions on egress gateway, and hopefully you got answers to all that you had asked. Let's go to the next question. What are the key differences between traditional DOKS cluster and VPC native DOKS cluster in terms of networking capabilities and limitations? Ingo?
Yeah, I think we touched on it before. Like the traditional setup was completely virtual networks. Everything that had to go in or out of the cluster had to be network address translated, which means if you have like multiple clusters talking to each other, you never see the real source IP. You always see like a node IP that things have been added to. And that is different with VPC native, because the network is really a network part out of the VPC, and you can set up things so that you really see the real source IP of a request. That comes in handy for certain logging situations, metrics, some tracing, if you want to correlate stuff. And it also is the basis for us to integrate it more tightly with other products and make things a bit more simple for you. On top of that, all VPC native DOKS clusters come with a Cilium mode that is called, basically we call it full eBPF mode. It is basically kubeproxy replacement strict, I think is the option that they call it, which means there will not be a kubeproxy process running on your cluster. It will all be handled in the Cilium eBPF part. And we also ship it with the IP masquerading agent. That means that all the masquerading options are very easy for you to set, because you can just fill in a config map and that will be respected by Cilium. And for those who are a bit more familiar with Cilium, the full eBPF mode is something that enables many, many more features in Cilium that we also are thinking about enabling for everyone in shipping once the majority is over on that new architecture.
Lovely. And we have another question, not exactly the same, but similar lines. Are there any plans to integrate things like Submariner.io? I'm not familiar with that, but I'm familiar with Cilium cluster mesh. So obviously with VPC peering, the service discovery is not an option, but any plans that customers can use Submariner or cluster mesh or similar tools?
I'm not too familiar with Submariner. I think it's also a cluster meshing solution, something like that. I think it's VPN based. I'm not 100% sure. We haven't talked about a specific solution. Also, not like Cilium mesh. For us, it might make more sense to do it on the VPC basis because that would be better integrated, and you wouldn't need to encapsulate packets in order to connect two clusters. So I don't think we can announce anything today that would point to a specific product, but a more tighter integration in terms of more easily talking from one cluster to another would be possible, or something that we're looking into. Yeah, we're totally looking for feedback here, what people want to see there.
Yeah, I think you put it rightly. And Felix, we'll be very much open. Right now, we are in the first stage of VPC peering, and we are open to feedback, and we'll make the right decision very soon. There is an interesting question, and I think Braden, you should answer this. What best practices should someone follow to build a globally distributed application? Because we have like so many DOKS networking features.
Yeah, that's a really good question. And I think it kind of is an extension of Uday's demo where, we have some of these new building blocks that, our customers are able to leverage to build out these applications. The first is that VPC peering, which allows you to have your application deployed into, 2 data centers and have secure communication between those two, which allows you to have this cross data center application. And then the second is specifically for DOKS, using an internal load balancer to front your application. This allows us to have just a secure way for us to route traffic into your cluster and into your DOKS application. And then that final thing is attaching a global load balancer to that internal load balancer. That allows us to have the GLB front all of the public traffic, and that way your application and your internal load balancer is not publicly accessible. That GLB layer will do a few things for you. One is it will allow you to spread traffic across multiple internal load balancers, either in the same data center or across multiple data centers. But it also will do things like it has a built-in CDN. So if you have static assets you want to cache, the GLB layer will cache those and serve those out for you. It also has built-in layer 4 and layer 7 DDoS protection. So your application will always be up and running and won't be able to be taken down by external DDoS attacks.
Got it. That makes a lot of sense. Thank you for explaining that.
Yep.
We have a couple of questions on the integration support for the VPC peering and load balancers. Uday, maybe this one is for you. Is VPC peering supported with the external cloud providers or services, like a lot of customers, if somebody is running MongoDB Atlas?
Yeah, at this point, like VPC peering is an internal construct where you can only enable VPC peering between the VPCs of DigitalOcean. If you want to connect from DigitalOcean to other clouds, we are working on another product called Cloud Interconnect, which would basically allow any workloads from DigitalOcean to be accessed from any other cloud or on-prem DCs. So that would be the product for that kind of a connectivity. We are still working on it. We will be launching soon. So VPC peering cannot be used for that.
Okay. So that's good to know that we have something in the plan.
Yeah.
The next question again about third party for the global load balancer. Braden, can global load balancer work with third party endpoint? I suspect it will be useful for migrations as well. Like,
Right.
and is there any requirement for such a configuration?
So at the moment, we do only support routing traffic directly to droplets or to regional load balancers, either public or internal. But we currently don't support routing to third-party endpoints. If people were wanting to do something like this, they would have to route traffic first to a droplet and then have that droplet be responsible for routing to the third-party endpoint, whether that's on another cloud or on-prem. But it's something that they would have to do manage for currently.
Interesting. Yeah. The other question, maybe Braden, you can answer that. Uday, you briefly talked about the network load balancer. So when do you use a network load balancer versus a regular load balancer that we have?
Is the question for Braden?
Yeah.
For me? Okay. I thought
Or
you said
you can answer that as well. Yeah.
I can answer it. So currently our regional load balancing product is considered more as a proxy. So when TCP connections come in, the load balancing layer will terminate that TCP connection and open up a new one to your application. And so it's acting as a proxy, and so it has to process all of the ingress and the egress traffic. And in this case too, the source IP address of the connection gets lost. So a lot of times customers will enable proxy protocol, which allows us to kind of propagate the original client IP on this kind of second connection. This new network load balancing product is a different kind of load balancer. Typically, it's called a pass-through network load balancer. So instead of having this dedicated compute and this load balancing layer, our networking fabric will take kind of all of these inbound TCP connections and directly route them to your application, to your pod. So there's no really proxy or anything in the middle. Traffic arrives directly to your droplet with the client IPs preserved. And then any of the egress traffic that comes or is leaving your droplet in response to that connection will go directly back to the client. So there's no load balancing layer that gets involved on the egress path. Typically, if customer, for a lot of DOKS customers, I would recommend using the network load balancer, especially if you have if you're running an ingress gateway or you have ingress nodes that are running Nginx or Envoy gateway or things like that. The network load balancer would be the kind of the best product for you to be able to scale out your application.
Got it.
There's one more question that fell through the cracks, I believe. Is there a multi-cluster service discovery working through the VPC? I saw this question earlier. Was that answered? If not, can
Yes. Ingo talked about it. Yeah.
All right, thanks.
Okay, so let's go to the next question on the list, which is, Ingo, this for you. How does private routing via VPC-Native clusters improve the security posture for applications?
Yeah, so first of all the like a VPC-native pod network is not different from a normal VPC internal network that you all know from droplets. Also, if you peer one VPC to another, we automatically peer the pod networks too, because we just see it as one. It's just a different numbering scheme, basically. The security upside of doing it through peering and the private VPC network is traffic does not go over the internet, even if strictly speaking, like the public thing, if you connect within a data center, doesn't really leave the data center itself. But you will have to open like certain firewall rules on the other side to make that traffic possible. And that's not necessary on a strictly private connection on the VPC. So it makes it simpler in that regard, and also safer because you don't have to fiddle with firewalls and don't accidentally have to open something that you probably don't want to.
Yeah, so it basically makes it so much simpler. You don't have to worry about any of those configurations. The next one, I see that Braden, I have a question for you. What mechanisms are in place to handle failover in case of a regional outage, which is a very common question? And can we configure our applications to take advantage of these features?
Yeah, good question. So if you're looking to handle, regional outages, I'd highly recommend, using the global load balancing product. It's based on what would be like an Anycast network. So if data centers are out or they're having networking issues, we stop advertising out the IPs to kind of like the public internet, and that will automatically allow your clients to route to different points of presence. And so that's kind of like the way that we have modeled this feature, so that we will automatically route around data center issues.
Got it. Yeah. So global load balancer is the one which is very helpful. The next one for you, Ingo, what monitoring and observability features are available for troubleshooting the cross-cluster networking?
So as of, I think, last year even, no, the beginning of this year, we ship Hubble with every cluster. Like as soon as you upgrade your cluster, Hubble will be installed by default. And that makes it fairly easy to troubleshoot traffic that's going in and out of your cluster, and even like within the cluster. In terms of cross-cluster troubleshooting, that's a bit different. We don't have a certain tool that would give you the full overview over two clusters at the same time in terms of peering. But since there's no address translation in between and you have Hubble on both sides, it's fairly easy to correlate both views and find out what's happening. In terms of the peering connections themselves, those are fully in our responsibility. So you can expect them to work just like you would expect a load balancer connection to work. So there's not really a need for you to dig in deeper if something is not working. That's on us.
Got it. The next question is, obviously we talked about a bunch of things that are supported. What are the current limitations or unsupported features in this whole new networking architecture that people should know? And what's on the roadmap? Maybe Uday and Ingo, if both of you want to take it up.
I can maybe start. There are two that come to mind that are close to DOKS. So as we touched on briefly before, you cannot swap out the complete network of a cluster that is not supported. And growing the network range, like the pod network range, would be supported from a Cilium perspective, but not in the mode that we're running it in. That is something that we are looking into migrating to, so that you could, once you reach the end of the capacity of your network, just add another one. And then another thing that we discussed quite a bit internally, as you may notice, if you create a cluster, you have to provide a range for pods and a range for services. Even though the services are not directly accessible, you would have to go through a load balancer. So we were thinking about making services or service IPs available from outside of the cluster without a load balancer. We opted for not doing it yet because there is some trickiness in terms of usability, because a load balancer gives you like added health checking, certain load balancer algorithms, stuff like that you would not get from a simple routing solution, basically. But if you have that kind of a use case, we would really love to talk to you, because that is something that we were wondering if it makes sense to make it available to people.
Yeah. And Uday, do you have anything to share?
Sorry, I missed the other part of the question. Can you repeat?
So basically, we talked about a lot of things which are supported. Is there anything which is unsupported?
Oh, yeah.
Yeah.
So related to the limitations on the VPC peering side, we want to mention that inter-team peering will not work. So currently, we don't support it yet. Anything within the team, but across regions and within the DC, any inter-DC peering and intra-DC VPC peering, inter-VPC peering will work as of today. That is one limitation on VPC peering. Global load balancer, we have one thing that I believe the Braden covered already. We do have the data center prioritization today, where customers can prioritize which data center to handle the traffic, but weighted prioritization is something is not available as of now, as you would have seen in Route 53 or other similar products, but we don't have that kind of a prioritization or traffic distribution today. So that's something that we are thinking we'll eventually try to provide. Those are the high-level top limitations today, these two features.
Perfect. And I see one last question, which is, Uday, I think you covered, but maybe you can speak again very briefly. How to set up a globally distributed managed Kubernetes that utilizes the global load balancer?
I think this.
I think that's more from me.
Yeah.
Oh, yes, Ingo, go ahead.
It depends where this is going. So, in terms of globally distributing a Kubernetes control plane, that's a bit tough in terms of latency, because think about certain region, let's say like one control plane node in Singapore and the other one in New York. You will have definitely over 100 millisecond latency between those 2 points. And that's not something that's great to work with if you have to talk to an etcd node. So we would really recommend to keep Kubernetes clusters regional and then use a global load balancer to balance in between those. And that can happen over regions, definitely. Like that's what global load balancer is for. But in terms of control plane, that should really be local. It's also, I know that there's the desire of having one API to talk to for deployment, and then it's just globally synced everywhere. But this also means like an outage in that control plane will take you down globally, and it will be your single point of failure. That's why it's generally not recommended. There are other solutions or services that would help you make like deployment with multiple clusters easier. For instance, look into Argo CD or many of the open source projects that just allow you to sync different deployment environments.
Yeah. Awesome. With this, I believe that we covered all the questions, and we are also at the top of the hour, so we have put some references. The slides will be shared with all of you. On a closing note, thank you all for joining us today and for all your thoughtful engagement and questions. We hope that you are as excited as we are about the new capabilities. If you'd like to dive deeper, feel free to reach out to our customer success team Or you can also use the DigitalOcean Kubernetes Slack channel. We are normally active there. Thank you again and have a great day.